Hello everyone. Today we are going to start with Microsoft.NET, and in the first session we are going to understand what is Microsoft.NET, what is .NET platform, .NET framework, and then we will gradually start ahead with the programming aspect of .NET. So in this module we will first start off with C# module, where we are going to cover the basic concepts of .NET framework. So the topics that we will cover would be identify the components of .NET Framework, understand the Visual Studio .NET IDE, which is the actual environment where we are going to write the code. Then we will have the introduction to C# programming language, and then we will see the compilers that will be used and what would be the overall structure for C# program, how to declare the variables, then initialize and use the different variables. We will be starting off with basic programs, and then we will see how to store and retrieve values from the different variables. We will also learn how to execute the C# program, compile them, debug the program, and how to basically create a basic application using C#. So starting off, first let's understand why we are going to use .NET. Microsoft created Microsoft.NET with a certain aim. One of the important aim was to have an environment where we can develop the software very easily with less time and which would be very powerful. Another aspect was to have it completely object oriented. So they provided the language that is C#, which is 100% object oriented programming language, and the other aim was to provide platform independence. So first we need to understand what is platform independence, then only we will understand the significance behind using .NET or how it actually works. Now to understand platform independence, we need to know what is platform dependency. For this, let us take one example. Suppose we have a machine M1 which has say processor P1 and the operating system is O1. Since this machine is having a processor P1, it is capable of understanding a specific set of instructions. The instructions may be say I1, I2, I3 up to say I100. These are the instructions which the machine M1 understands. Coming to machine M2, which is a different machine. So it may use the same processor or a different processor. So I have used here P2 and O2 to indicate a different processor and a different operating system. Now since the processor has changed, the instruction set may also change. So here the instruction sets we are using would be I1, I2, I3 up to I50, J1, J2 up to J50. Now when we have a program, we first write the source code, which may be say something like first.cpp. Then we go for the compilation process. After compiling the code, we get the binary, that is we call it as .exe. .exe has the instructions like I1, I2, maybe I30, I55 and I70. These are the instructions which are generated after compiling the source code on the machine M1. Now let's say I copy this source code and take it to the machine M2. On this machine, if I try to execute this binary, here you will see I1 is present, I2 is present, but I30 is also present, I55 and I70 are missing. So this binary code may not execute on this machine M2. This is basically the meaning of platform dependency. That means if I create a source code and I compile it, if I give it to the client, then I am saying there is no guarantee that this code will execute on the client's machine, which is definitely not the case we are expecting. If we are giving a code to the client, we expect that it is guaranteed to run on the client's machine. So we need to find a solution to this problem. The problem occurs because we compile the code on the machine and the binary which is generated on the client on that machine is very much specific to that machine. That is where the problem arises. So let's find a solution for this. Now what we will do is, instead of compiling the source code into binary on the particular machine, let's break this compilation process into two phases. So now we will have two-stage compilation process. One that is done on the developer side, and the other one part of the compilation will be performed on the client's machine. So on the developer's machine, we will have the source code. Then we compile the source code. So it is that compilation is necessary because we want to make sure that there are no errors in our code. And then instead of generating binary, we are generating something which is similar to an assembly language code. We call this as MSIL code, Microsoft Intermediate Language Code. This code, if you observe, it will look similar to assembly language code. So assembly language is also known as a low-level programming language. Compiling assembly into binary will take very less time. So the overall process is going to become very fast. Now this MSIL code we are going to give to the client. So client will now perform the second stage compilation and generate the native code, or we call this as a binary code. So this is the idea behind. Now see, second stage compilation is being performed on the client's machine. So it is guaranteed to run on the client machine because the instruction set will be generated based on the processor which is present on the client side. Now in this case, the important point is that when you perform the compilation, the exe is not getting generated. Now, if you look from the client's perspective, as a client, we never expect the client to perform some compilation to run the code. So client will simply say that I want to double click on some icon and my software should be up and running. So for the client satisfaction, we will do the compilation and we will generate a code which will have the extension as .exe. But inside the exe, binary is not present, rather than that it is actually the MSIL code. When the client will double click on this exe, silently the second stage compiler will get loaded and it will convert the code into the native code. That is why this second stage compilation is also known as just-in-time compilation, or it is known as jitters. This is how the platform independence is achieved using .NET. Now this part which is done on the client's machine, so we are basically going to give the MSIL code to the client. Now in order to perform the second stage compilation, some component or some compiler must be present on the client's machine which will do this compilation. This component which should be present on the client machine is actually the .NET framework. So .NET framework has the compiler to convert the MSIL code into the binary, plus it has some additional components that will support the overall functioning of the actual code. See, once the binary is created, it is executing. During the execution, there may be certain requirements. The application may ask for some memory, it may ask for some multi-threading library or some database related library. These libraries will be provided using the .NET framework. So that is the component that must be present on the client side. So here now we will see what are the components of .NET framework. Here we will see that .NET framework will basically comprise of certain elements that must be present on the client's machine. Another important goal which .NET framework targets is language interoperability. Now what is the meaning of language interoperability? Earlier, Java was very popular, and the important point why Java was popular was it was platform independent. But in order to use Java, we had to learn the programming language Java. So after learning Java, then only I can use Java. But with Microsoft says that I don't want to force you to learn a new programming language. Why don't you continue with the language in which you are already comfortable? So at that time, there were many programmers who were working with Visual Basic. Some were very comfortable with C++. So with that aim, Microsoft says that let us develop the product using different languages. If you are comfortable with VB, continue using VB. If you're comfortable with C++, continue using C++. Now, of course, we are using C# in place of C++, and for VB, we are using VB.NET. So depending on your comfort level, you select the programming language, write the code, and then after writing the code, we perform the first stage compilation. The output is MSIL code. So whether the code is written in any programming language, the output would be MSIL code. When the MSIL code is generated, the platform dependent part is gone. Now this part is completely language independent. So when you give this to the client, now the second stage compilation is done and the native code is generated. So here we can see Microsoft introduced .NET Framework to make applications more interoperable. Interoperability of application means ability of applications developed in different languages to be able to work together and exchange information. That means in one project I would be able to use multiple projects at the same time. Now the different here you can see the .NET framework is designed to make significant improvements, that is code reusability, code specialization, resource management, multi-language development, application security, application deployment and application administration. When you use .NET you are going to get these benefits that will be the resultant output that will be seen in the final product. And how these are achieved, that we will learn gradually when we learn C#. Reusability we will achieve using inheritance. Specialization, because since we are using classes, namespaces, we will have the code which will be very much specialized. Now, here we will see that .NET Framework consists of all the technologies that help in creating the running applications that are robust, scalable and distributed. Now, what is the meaning of robust? An application which does not crash easily will be considered as a robust application. Scalable application. Today I am designing an application for say 50 students. Tomorrow the range may increase to say 500. So my product should easily accommodate the changes. That is the meaning of scalable. Distributed, that means it should not be restricted to a specific machine. I should be able to run it on multiple machines at the same time. That we are going to use, for this we are going to use ASP.NET. And .NET offers a complete suite for the developing and deploying applications. It will have .NET products, .NET services and .NET framework. Now, the .NET framework is a revolutionary platform that helps you to write the following types of applications. We may create Windows applications, web applications and web services. We can also create console-based applications. That is not mentioned here. Why? Because console application is basically for learning the concept. There we focus mainly on the understanding of the language features. Nowadays you will not see any application which is usually console based. Most of the times we require UI based applications that will be created using either WinForm, or we will see based on web applications. What are web services? Web services are basically used to provide some services or some set of functionalities for the end user. So web services will focus only on the services rather than the UI part. UI part will be mainly covered by Windows and the web applications. .NET Framework applications are multi-platform applications. It has been designed for multiple languages like C#, C++, Visual Basic, JavaScript, COBOL, etc. So there are multiple languages for which the compilers have been provided and interoperability is also supported. Now we will see what are the different components that will be used for .NET Framework. So .NET Framework will comprise of Common Language Runtime, that is known as CLR, .NET Framework Class Library, Common Language Specification, Common Type System, Metadata and Assemblies, WinForms, ASP.NET, ASP.NET Ajax, ADO.NET, WWF, that is Windows Workflow Foundation, Windows Presentation Foundation, Windows Communication Foundation and Link. So these are the important components that will build, that are grouped together in order to create the .NET framework. Now let's see them in detail one by one. So first we will understand what is Common Language Runtime. In order to understand this, see, when we are running one application, so if you go to if you press Control or Delete, you go to Task Manager, there you see a process is running. This process is completely handled or taken care of by the operating system. So my whatever requirements my application has, those are serviced using the operating system. Now, when we say .NET is platform independent, that means .NET says whatever is the need of my application, I will service that need. I will not keep on asking the operating system for various requirements. So what .NET does, it creates a small operating system around the .NET application. That mini operating system is known as CLR, Common Language Runtime. This runtime word itself is telling that it will come into picture when the application starts. So as I told you, after the second stage compilation, the binary or the native code is generated. This code is running inside the CLR. So whatever is the need of that environment, that will be serviced using the CLR. So this is the environment where all the programs using .NET technologies are executed. Provided services such as code compilation, memory allocation, and garbage collection allows the execution of code across different platforms by translating the code into intermediate language code. So compiling the code, converting into native is also done by CLR. So once the code is converted into IL code, then we say it is a language neutral code. It doesn't have the specifications of a specific programming language. Now what is IL? IL is a low level language that the CLR understands. IL is converted into machine language during execution by the just-in-time compiler. During JIT compilation, code is also checked for type safety. Now C Sharp, the programming language that we will learn, is known as strongly typed language. Strongly typed language means one data type cannot be directly converted into another data type. They should be compatible with each other from every perspective, then only the conversion would be allowed. Otherwise, the conversion will not be allowed. Blindly, one data type cannot be converted into another data type. With this feature, the code crashing would be reduced to a very great extent. That is why we say the application is robust, because it is not allowing such features which may lead to the crashing of the program. Let us say I have a data type of say employee and I'm converting it into say book. This is not logical that the employee is being converted into book. So if this conversion is blindly allowed, then the program may crash. So now .NET says I will not allow such type of conversion. First the type will be checked. Only if they are compatible, then only the conversion would be allowed. Otherwise it will not be allowed. So that will make our application more robust. Okay, now let's go ahead. So here we can see that we have the just-in-time compiler. Now this compiler is going to create low-level language into the machine language that is generated by the just-in-time compiler. So you can see now that this code that will be generated during the just-in-time compilation, it will be running within the CLR. This is the environment for running the .NET application. Outside the CLR will be the operating system. So operating system is going to interact with the common language runtime rather than the actual application. So if my application requires memory, it will be serviced using the CLR. Whatever is the need, that will be handled by using the CLR rather than the operating system. So we don't depend on the OS. That is why we call our application as platform independent. CLR consists of a set of common rules followed by all the programming languages, which are known as common language specification. Now we need to understand this point. See, we are saying we will provide language interoperability. Now, how this will be achieved? If I am writing a code in C# and I want to use it in some other programming language like VB, how this will be possible? Now, C# is a case sensitive language, whereas VB is not a case sensitive language. So in C#, I may create a variable, say int x, comma, and I may write a capital X also. So using different cases is allowed in C#. Now this code, if I take into VB, then the VB compiler will say variable redeclaration error. Why? Because X, small x and capital X are one and the same thing for VB. So in this case, it will not be possible for us to use the C# code directly into VB. So if my intention is to create an interoperable code, we must follow some rules. The rules, one of the rule may be, while creating the variable, please take care of the case. That may be one of the rule. Like this, there are certain rules that every developer needs to follow in order to make it language interoperable. CLS enables an object or application to interact with objects or another applications of another language. One of the specifications defined in CLS is common type system, which provides the type system that is common across all languages. Again, see, when we are using different programming languages, every language has its own set of data types. And when we are speaking about interoperation, for example, in VB, suppose I am using an integer, keyword is integer. In C#, the keyword is int. Ultimately, both are going to reserve memory block for an integer. So if I want the interoperability, they should drill down to some common type, and the memory requirement, the rules and regulations, everything should be same. That rule is defined by common type system. Common type system will speak about the type hierarchy, means what should be the integer, how much memory requirement should be allowed for an integer, double, and the common data types that are supported by all the programming languages. If using CTS or targeting CTS we are writing the code, then we can have it language interoperable. CTS defines how data types are declared, used, and managed in the code at runtime. So now you can see that we have the common language runtime, which has the just-in-time compiler, plus it has common language specification and common type system. Because using these, we are developing the code which is targeted to be interoperable. CLS enables an object or application to interact with the objects or applications of another language. CTS defines how data types are declared, used, managed, and managed in the code at runtime. So CLS basically speaks about the specifications or the rules that are applicable for the language, and common type system basically focuses on the data types. Compilation is the process of creating an executable program from the source code. So when you compile a program in .NET, the conversion of the source code to the machine language happens in two stages that we have discussed earlier. The first stage, compilation translates the code into IL instead of machine language or the assembly language. And in the second stage, the conversion of IL to machine language is done at runtime by the JIT compiler. Now here we have the program code, then we perform the compilation. Output is the IL code. Now, till now we were speaking that the output is only the IL code. But besides IL code, some additional information is also generated, which is known as metadata. Now, what is metadata? Metadata means data about data. So, this part that is generated after, as a result of the first stage compilation, it is one single deployable unit. That unit is known as an assembly. What is the name of this assembly? What is the version of this assembly? What are the classes present inside this assembly? All this information is present in the metadata. So metadata is something like a documentation that we can refer for understanding the part that is present inside the assembly. IL is the actual code part. Means whatever coding is present, business logic is present, that is present in the IL. Information about this assembly is present in the metadata. During execution, CLR performs the following tasks: loading assemblies and identifying the namespaces, JIT compilation and garbage collection. What are these that we will see in detail a little later. For the time being, you can understand that when you compile the particular code, first stage compilation, the IL code is being generated, and then we have the just-in-time compiler to convert it into the binary. Garbage collector is used in order to manage the memory. See, when we are running an application, there are so many objects that are being created and that are getting stored on the heap, which are going to consume the memory. After a particular duration, we may not use them, but still they are consuming the memory. So garbage collector can be used to free up that memory so that that released memory can be used by the other objects. The code developed in .NET is known as the managed code. Why it is known as managed code? Because the memory requirement will be completely under the control of the CLR, and because of the means, even if we are consuming lot of memory, then garbage collector will come into the picture to release that memory. So everything is totally under the control of CLR. That is why we call this as a managed code. So the chances of program crashing, it becomes very less. CLR manages the compilation and execution of the managed code to ensure proper functioning of the code. An assembly contains IL and metadata that was generated during the compilation. Instead of compiling the complete IL code, JIT compiler compiles only the code that is required during execution. Now this is again a very important point. If you observe .NET, as we discussed, .NET has so many components. So all the components we don't need at the same time. And similarly, in our application, we have so many features that we have added. So we don't need all the features at the same time. For example, there may be some exception handling code, some error related code is there. That code we require only when that error occurs. If that error doesn't occur, we don't need it. So why to load the entire code at the same time? Because it is going to consume the memory and it is going to slow down the overall process. So only that component is added that is needed at the particular time. Later on, the remaining part of the application and the CLR will be loaded as per the need. Now let's see what is a framework class library. .NET supports a lot of features like file handling, database management, then collections, etc. All this, all these classes are present in set of libraries. These libraries are considered as .NET Framework Class Library. So we have different languages. For those languages, we have the code for string management, data collection, library, database connectivity, etc. All these classes will be present in the library. So here we can see that we have .NET Framework class library. Now this class library is quite huge. Many classes are present here. So assume that you have a college. In a college, there are so many students. If I place all the students in a single room, then it will be very difficult for me to identify which student belongs to which department, or I should say which year or which course that student is doing. So what we are doing, we are grouping the students according to their courses. Now within the courses also we may further have these sections like first year, second year and so on. So this classification makes us easy for it makes us easy to understand which student belongs to which group. Then to talk to that particular group becomes easy for us. Same thing is done with the classes. All these classes are further divided into groups. That group is known as a logical compartment. So these groups will be created, and say, for example, database related classes, they will be placed in one group of database related operations. All the classes which perform file related operations, they will be grouped in a separate section. These groups will be known as namespaces. So we have these libraries which will be again categorized on the basis of their functionality, and we group them using namespaces. Namespaces help you to create logical groups of related classes and interfaces which can be used by any language targeting the .NET framework and are stored in assemblies. An assembly is the single deployable unit that contains all the information about the implementation of class, structure and interface. As we discussed the two-stage compilation, after the first stage compilation, I said that we get the MSIL code. That MSIL code that we get, that is what we are going to give to the client. So that becomes our single deployable unit. That unit is known as assembly. User and program interfaces. At the presentation layer, .NET provides three types of user interfaces: Windows Forms, Web Forms, and Console applications. .NET provides a program interface called Web Service to communicate with remote components, which we are going to learn gradually. So here we can see Windows Forms, Web Forms, and Console applications. WinForm would be used for window-based application. Web form would be used for web-based application, which will be basically used on internet, and console application would be used for character user interface. So basic purpose of console application is where we want to learn the concept. We want to focus on the concept rather than the UI part. So we use console application. Some advantages of .NET Framework are consistent programming model, multi-platform application, multi-language integration, automatic resource management, and ease of deployment. Now, after this, we are going to go ahead with Visual Studio IDE.